So I'm Vincent Blondeau. For the ones that doesn't knows me, I was in the Stéphane Ducasse team as a PhD. 2 years ago, I spent 1 year in LAM research in the USA last year with Chris there. And now I'm working in Lifeware, which is a company that make life insurance applications. And I will present you the test sucker that we use in our company that allows to convert production data to local source code. So first, I would like to focus a bit on the company. So it's a fully Swiss company that's been created 21 years ago. And there was, at the beginning, 5 founders, which are still working with us in the open space and writing code every day and fix bugs, etc. We have 60 employees, which are with a strong background and skills and good methodology to answer the request of our customer. We also have 4 redundant data centers, 2 in Luxembourg and 2 in Switzerland to carry all the data of the world customers. So to give you a bit what we are doing, we'll support 8 languages and almost 1 billion policies. So we manage 1 million of contracts, of life insurance contracts. We have 100,000 people that can log to our platforms for all the clients we have. We manage 25 billions of euros in value. And we have more than 200 policies that exist when we regroup all the customers we have. The technology part is the following one. So we have our development that is done in Visualworks. So every code we write is done in this environment. And after we have seamless integration with Gemstone, which is the database that's where the clients are connecting to and that supports the production and the test environments. In our system, so the object is all over. We have 70,000 classes in one image on the Visualworks system. We have, inside the classes, if we group them all, we have 1.5 million method. And if we regroup all the productions, we have 3 terabytes of persisted object. So it's quite a huge system that we have. We also do some extreme programming. So instead of the classic analyzing, design, implementing and testing suite that most of the people using in the waterfall development, we choose to have an extreme programming development. So we first get the requirement of the clients, write the tests, then do the implementation, and then do some refactoring to improve the design and be ready to have new requirements. So this small cycle allows us to be very fast to respond to any customer request, and we can respond in 5 minutes for the critical request, or maybe 2 days for more complex stuff. And we have a new version of the system every week, so we release new feature continuously to the customer. To support this, we need automatic testing because we don't want to carry such a code base with no automatic test. We don't want to do manual testing. So we have 95,000 tests in the code base that are run every day, up to 60 times a day. And it takes 10 minutes to run them all on a distributed architecture. If we don't have a distributed architecture, so with one core, it's about 3 days to run them all. Yes, 3 days. So we have 320 processor to help us to run all the tests. So we can run the test at developer level. And for each time we want to commit something, there is all the test of the whole environment that will be run and give us the feedback if we can integrate or not. We also have some coverage information about which part of the code is tested and what is not tested. I will also need to tell you that we have contracts-centric system. So it means that everything in our system is relative and turning around of the contract. But I will show you better in the demonstration how it's working. Okay, should be good like this. Okay, so we are on the test environment here for one production which is called Square Life. So it's one of our own life insurance company. So here we are browsing a contract. So that's the contract of Corey Neolasioptera, which is generating names for anonymous reason of the contract. So we have information about the insured, the policyholder, what the guy should pay every month, and how we compute it, and where the data, the bank should be paid if there is any payment that should be done. We also have all the history on the contract. So it means that for each thing that happened on the contract, we track what happened, how it happened, and who performed the action. So the application is the first beginning of the contract. After dynamic increase is when the client puts more money on his policy. And we have several other tools that are not important in this demonstration. We also have some graphical view on the different accounts that we have. So it's very, how we say, for the accounting business, because we have to do some accounting reports to the customers for them to know what should be done and to get track of the money. So we have this kind of values too. And yeah, so I will try to show you how we can convert this contract to a local test. So for now, it's running in production in the test environment, and I will show you how to convert it, how we do to convert it in the test. So we have some tools to be able to inspect the model. So first, I will show you with one tool how it works. So a dynamic increase, because it's a simple one. So I want to inspect the tool. So I just click here, and it's open a window that says Gemstone object that is represented in the Visualworks environment. So here we have all the information about when the tool have been done, on which contract is applied, what is the status, etc. So for each tool, what we have is a method that is called write-sucker event that will take the stream and get all the information about how to reproduce the tool or the application and all the information about the contract. So get the data from the Gemstone system and copy it inside the Visualworks one. So here we just write the stream of the event, and more particularly here it's a tidy up batch event. So if we browse this class, we'll see that there is some information about when it should be done, which is a timestamp. And we have a template that will describe what should be run, what should be written inside the test. Inside the test setup, to be able to generate this event. So here, we just have to run this line of code, which say Square Life Test Builder. So it's a builder specifically for Square Life, for our Square Life production. And we say build and the contract number. So the contract number, it's just the number we have here. So if I run this, it will automatically connect to the Gemstone database and get every object and convert every object according to the events that are defined to our Visualworks code. So after sometimes you have to synchronize every code, and once it's done, it will generate the test methods. So here we have the test method here, which is just replaying all the events that happened and show them in the browser. All the events is all the history that happened every year since the beginning of the life of the contract. So we are able to navigate in the time to be able to see which is the state of the contract at which time. So if I show you the test here, I can run it and find it in the test palette. So it is this test. If I run it, it will be green. So it means that it's able to replay all the events. And I can even open it in the browser. So and now we are in the test environment with the same information. So we manage to get all the information locally. And if you can compare both contracts, we see we have the same information, almost the same actually. Can I zoom in a bit, please? Yes. So we have the same information about the policyholder. So if I click on the policyholder, I will see that he has the same address, same birth name, everything. Yeah, almost a phone number. So there is always a process of manually write which part of the tool should be converted. So it can be sometimes a bit different. But mostly we have all the information we want to be able to run some tests on it. So after, what we can do is to ensure that we can continue to write the test. So here, what I can write, it's a method to compare the page we have and to create a test for it. So I would get the contract that is in the test. I want to have the first tab. I have a selector, which is the representation we have for the page locally that will be testing against. And we have a clerk, which is the user that will navigate on the page. Because we have some rules that say that some clerks have more rights than other people. So if I write that, and after I run the test here, it will be yellow because I added a comparison that it's false. And after, I see that's the representation of our page in our test, and that's what is expected. So I can just accept, and here the test will be green, and we ensure that the page will be having always the information that are written in the test. So if we change something in the page, we will see that the test will be invalid. So I can show you, for example, here, what we can do is just inspect one widget, for example, the insure widget, and browse it. and remove, I don't know, the name here. So I remove this field. I save it. And after I go to the test suite, no, not that. And I run the test again, and if I did it properly, it should fail and tell you, in this case, what changed. So here we just remove the name, and after we can continue to develop with the certainty that we do not modify important data between two versions or when you do some modification. So yeah, that's it for our test sucker. I will present you now some limitations that we have on it. Yeah, I planned some backup slide in case of. So it does not handle manual changes very well because sometimes we can interact quickly on the production database to just fix some information, but that will not be represented inside our in one tool. There will not be exactly the code we executed, so that's why there is some discrepancies between the local test and the production version. For now, it has to be implemented for each tool that we do, so it's quite a tedious task and quite repetitive. But maybe with the tool of Julien to generate code source, it can be very interesting to see how it can impact in this. And you see, you can have very complex templates that we have to generate. And after some refactoring, it will give you some more concise method and more concise information. So in short, what we have is we need this kind of tool to be able to perform extreme efficiency and to be able to be very efficient in giving information to the clients. And for that, we have the contracts tools that help us to gather all the data. And then we are able to write the test according of what the client wrote and be able to reproduce them in the local environment and create tests. So and regression testing for this. And also we are looking for some people that would like to work with us to solve this kind of problem. So very innovative problem solvers. It's real world problem with real clients, and we want to design innovative solution. And we also plan to progress to go to Faro from Visualworks to Faro for our development environment. So there are some positions open either in Luxembourg or in Switzerland. And you can write to this email if you are interested, or just contact me, or the guys that are here in the middle. Thank you. If you have any questions. Yeah.
Hi, you mentioned that you use some sort of distributed environment to run the test.
Mm-hmm.
You have roughly 100,000 tests. Can you elaborate more on that a little bit?
So what we have is we have several machines with multiple processors, and we spawn one image by processor because we don't have multi-threading either in Visualworks. We cannot use it. So we have to spawn images for that. And after we dispatch from the master image, which test should be run by each slave. And after we run all the tests and they report back to the master, and the master agglomerate all the results and say it's true, false, and you can replace them on the master and see what's happening. Is good? Okay, thank you.
So this environment, distributed environment for running the test, do you just like randomly assign the test for each machine, or you have some intelligent grouping to like profit of test suits or more complex like startup of the
So
testing environment?
what we have is so at the beginning it was randomly, but we saw that if we put the longest test, so the tests that are taking more time to be run first, it will be faster, and we can win 2 minutes on the running all the tests.
40%.
Hmm?
So that's like 20% of the game.
So on 10 minutes, it was 12 minutes. So if we sort them, I think it's 2 minutes less, right? Yeah, kind of. Yeah. So that's the main strategy, and the new tests are run first. So first the new test, and then the longest test, and after the rest. But there is no really order yet. Any other question?